we are going to be talking about something called molar mass, okay? And so this is a big part of chemistry going forward. This is what allows us to measure how much chemicals we need to make something and how much we actually end up making. Okay, so before we get started, we're going to have to define something called a mole. Now, it's not this ugly animal that you guys are probably very familiar with. Right? It's freaking disgusting. Okay? If you think this is cute, there's something wrong with you. And dude, this is literally nightmare fuel right there. All right, anyway, so we're gonna get started with some types of measurements that we are comfortable with. So if I have a dozen of something, how many do I have? 12, yeah. And you guys don't need to write this part down. If you have a pair of something, how many do you have? 2. And if you have a trio of something, you have 3. Okay. So in chemistry, when we say mole, it's a way of counting something. Okay. So just like how we count, if you have 12 of something, it's a dozen, a pair, it's 2. In chemistry, you can have a mole of something. Okay. This is a unit of measurement. Okay. And again, it's not this animal right here. Okay. All right. So when you have a mole of something, you have this much of something. So write that number down. So you have 6.02 times 10 to the 23rd of something. Now, this doesn't make much sense, so I kind of wrote it out for you. You guys don't need to write the long one, but just write that 1 mole equals this number right here. Okay. How much is this, though? I feel the same way. Billion, trillion, quintillion. Yeah, 1 mole is this. Yeah, you can just write the scientific notation, the top one. Okay, so like we said, when you have 1 mole of something, you have this much of something. So just to compare it to our other units of measurement, if you got a dozen donuts, you got 12 donuts. If you have a mole of donuts, you have this many donuts. If you have a pair of shoes, you got 2 shoes. If you got a mole of shoes, you have this many shoes. Okay, so it's just a way of counting a lot of things at one time. Okay, now the reason why a mole is such a big number is because atoms are super duper duper small. Okay, they're so small that you have to count them this many at a time. You guys okay? You guys sound like you're having a collective stroke or something. All right, so if you guys have a mole of something, you have this many, okay? All right, now this number right here is called Avogadro's number. So write this term down as well. Avogadro's number. It's not avocado's number, but sounds kind of familiar, similar. Okay. So 6.02 times 10 to the 23rd is Avogadro's number. And we use it to count atoms because they are super duper small. Okay. Just the highlighted term right there. No. Unless you really want to. Yeah. 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 Avogadro's number is this thing right here. So you should have wrote that down already. Okay, so let's talk about what a mole, how we can use a mole in our calculations now. Okay, so today's lesson is called molar mass, right? And molar mass is the mass of 1 mole, okay, of an element, of a molecule, whatever. So when you have 1 mole of an element, the way that you can find out how much 1 mole weighs is this number right here. So we're finally going to use that number on the bottom of the periodic table. And so the number on the bottom tells you how much 1 mole of whatever element it is weighs. Okay, so 1 mole of xenon is going to weigh 131.293 grams. Okay, so if you guys look on your periodic table, look at hydrogen, number on the bottom of the box is 1.01. So 1 mole of hydrogen weighs 1 gram. Okay. All right. So far, so good? Okay, so with that being said, I'll let you guys try number 1 on your own. I want you guys just to write on your paper, what is the molar mass of phosphorus? Okay, just look it up on your periodic table. Just write down your answer. Again, you don't need to copy down the questions for this class. Alrighty, guys. So in order to find that, all we got to do is look on the periodic table. Look at phosphorus. The number on the bottom is 30.97, which means that phosphorus has a molar mass of 30.97. Pretty easy, right? Okay, now the one thing I do want to mention is that when we write molar mass, we can't just write the number. We need to write the unit of measurement. So there are two ways you can write the unit of measurement. You could either write grams per mole. Okay, so per every 1 mole, it weighs 30.97. Or you can write it like this, 30.97 grams equals 1 mole of phosphorus. Okay, so either way works. You can write it however you like. But you got to add the units of measurement behind it. Okay? Alrighty. Any questions about that? Easy peasy? Okay. It's going to get a little bit trickier, though. I respect you guys too much to make it this easy. All right, so we're going to move on to more complicated compounds now. So we're going to find the molar mass of meth. Now, we learned how to find the molar mass of just one element, right? All you got to do is look it up on the periodic table. But we're going to be working with molecules where you combine the elements together. Okay, so let's take a look at meth. Okay, what we want to do to find the molar mass of meth is we want to figure out how many of each element there is first. So how many carbons are inside of meth? 10. So we got 10 carbons. Okay, how many hydrogens do we have? 15. So we got 15 hydrogens. And then how many nitrogens? 1. Okay. So meth is made up of all of these atoms together. Now what we can do is we can use the periodic table to figure out how much each of these weighs, multiply it by how many there are, and then if we combine it, we can find out how much the total molecule weighs. Okay, so let's start with carbon. You go to the periodic table. What's the molar mass of carbon? Yeah, 12.01. So we're going to write 12.01. So we can replace the carbon for 12.01. And then you multiply that by 10, you'll get 120.1. So all of the carbons inside of meth, they give you a mass of 120.1 per mole. Okay, let's go to hydrogen now. We look up hydrogen on the periodic table. Hydrogen has a molar mass of 1.01. So we can just replace the hydrogen right here with 1.01. Okay. You multiply them together and you should get 15.15. All right, next we can look at nitrogen. Nitrogen on the periodic table is 14.01. So we can just replace the nitrogen with 14.01. So this is how much all of the components of meth weigh. And so if we want to find the molar mass of the entire compound, what do you think we should do with all these numbers? Yeah, we just want to add them together. Good. So if we add all three of these together, that will give you the molar mass of this molecule. Okay, so that's how you find molar mass for big molecules like that. Okay, so might help to pull out a calculator, but I'll do this one for you guys. 120.1 plus 15.15 plus 14.01. You get a molar mass of 149.26 grams per mole. Okay, make sure you remember the units of measure. Okay, so if you have a mole of meth molecules, it will weigh about 149 grams. Okay. Alrighty, any questions about that? Easy peasy? Okay. All right, so I am going to give you guys a couple minutes to work on number 3. Now, what I want you guys to do for number 3 is I want you to find the molar mass of all of these molecules. So if there are 4 different molecules inside of this reaction, I want you to find the molar mass of all of them. Now, I do want to give you guys a quick hint for going forward. There are a couple elements that you can always round the numbers, okay? And these are the 3 that you can always round, or 4. Okay, carbon on the periodic table is 12.01, right? You can just always use 12. Okay, so for carbon, you can always use 12. Hydrogen is 1.01. You can always just use 1. Nitrogen, you can always use 14. And oxygen, you can always use, oh, you don't need to round that one, but yeah, you can just do those 3. So those are the 3 you can always round down. You can always just use that. That'll just make it a lot easier to write and to do your calculations. Okay. So with that being said, I'll give you guys about maybe 3 minutes. You can work with the person next to you. I want you guys to find the molar mass of all 4 of these molecules, and then we'll move on to the next part, okay? Okay, so if we take a look at this balance equation, there are 4 different molecules in the equation, right? The first molecule that we have is CH4. Okay, so molar mass of CH4 is very easy. C is 12, H is 1. So if you have 4 H's, that's 4. So 12 plus 4 is 16. So 16 grams per mole. So CH4 has a molar mass of 16 grams. All right, let's move on to the next one. The next molecule is O2. Okay, O2 is made out of 2 oxygens. So 16 times 2, or 16 plus 16, is 32. We got 32 grams per mole. Okay, now, yeah, so the 2 is what might trip you up, but the 2 just tells you how many you need to balance it. It has nothing to do with the molar mass. So if I drew this out for you, basically what this reaction is telling us is that you have 1 CH4 molecule, and it's going to combine with 2 separate O2 molecules. This is what the left side of the equation is telling us. Not when you do molar mass. Molar mass, you're looking at these individually. So this guy is 32, and this guy is also 32. So we're not combining them because they're separate molecules. It's a good question. Okay. All right, let's move on to the third one. The third one is CO2. CO2 is 44 grams per mole. And then the last one, H2O, is 18. Okay. Yes. CH4, yeah. If you look at carbon on the periodic table, it's 12, right? Hydrogen is 1. But if you look at CH4, there are 4 hydrogens, right? Yeah, so 1 times 4 is 4, plus 12, 16. Any other questions? Easy peasy? Okay, don't worry. You'll be doing this all year, guys. It'll be easy by the end. Okay, so what we're going to do now is we're going to do something called converting. So I'm going to give you grams, and you're going to have to turn it into moles, or I'll give you moles, and you got to turn it into grams, okay? So I'll go through a couple problems with you, and then I'll have you try one on your own, and then I think we're done after that, okay? Okay, so I want you guys to refer back to number 2 because we're going to need the molar mass of meth for this problem. Okay, but what we're going to do is we're going to have a problem like this. So Walter White, I think he looks like Mr. Peppic, if you guys know who Mr. Peppic is. Mr. Peppic, he produces 1,000 grams of meth. How many moles of meth did he produce? Okay, so we're going to be doing a lot of math going forward in this class. Now, whenever you have a problem like this, the first thing you guys want to do is you guys want to write down whatever the starting number is, okay? Okay, whatever number I give you in the problem is going to be your starting number, okay? So if we take a look at this problem, what's our starting number? Yeah, 1,000. Okay, but we got to be very specific. We have 1,000 grams of meth, okay? Yeah. Sorry if I was unclear. Yeah, whatever number basically is in your problem, that's your starting number. Okay. And then what you want to look for is you want to look for what unit of measurement you want to end up with. Okay, so what are you looking for in this problem? So if we take a look at this problem, we start with 1,000 grams of meth. Okay, now what are we trying to turn that into? What are we looking for? Yeah, we're looking for moles of meth, right? So that means you're going to start the problem with 1,000 grams of meth, and you want to turn that into, you want to convert that into moles of meth. Okay? Make sense? All right, now this is where I get very picky about how you guys do these problems. And it might seem kind of redundant for right now, but later on, I think in the 2 lessons from now, it's gonna be a lot more helpful if you guys do it the way I teach you. So I'm gonna require that you guys solve these problems the way I teach you guys, okay? So what we're gonna do is we're gonna write down our starting number. So you're gonna write down 1,000 grams, and then it's gonna be meth. So we'll just write C10, H15. Okay, that's our starting number. And so what we're gonna do is we're gonna set up a fraction next to it. So we're gonna multiply it by a fraction. So draw a multiplication sign and then draw the fraction line. And so what we're gonna do is we're gonna put a number on top of the fraction and a number on the bottom of the fraction. Okay? So far, so good? So what we're gonna do is we're gonna use the molar mass of meth that we found earlier. We said earlier that meth is 149.26 grams in 1 mole, right? And so what we're gonna do is we're gonna plug this into the fraction. Now, we need to figure out where we should put the 149.26. Now, this is the reason why we always write the unit of measurement, because let's say, for example, we have a problem like this, okay? Just refer back to your math class. Just think back. If you have a problem like this, if you have, X is probably a bad example. Say I have Y times a fraction and then YZ. What can we do if we have a number on the top and bottom of a fraction? So we don't multiply them. What happens is if you have something on the top and bottom of a fraction, you can cancel them out. You can get rid of them. Okay, so the only thing left over is going to be on the top. And so if you guys notice right here, we have grams on the top of a fraction, right? So we want to get rid of grams and turn it into moles, right? And so what we're going to do is we're going to put grams on the bottom of the fraction, and we're going to put moles on the top, okay? Okay, and the reason why we do that is because if you have something on the top and bottom of a fraction, if you have grams on the top and bottom, the grams can cross each other out. Okay, does that make sense? Hopefully, too early for math. All right, now what we have to do is we need to put a number next to these units of measurement. So if you look at grams, what number is next to grams? Yeah, 149. So we're gonna put 149.26 on the bottom. And then if we look at moles, what number is next to moles? If there's no number next to it, it's not 0, 1. It's 1. So there you go. That is your equation. Now, like we said earlier, the grams are able to cancel out. And if you guys notice, the only unit of measurement we have left over is moles, right? So all we have left over is moles. And then after that, we just need to do the math. Okay, now the math for fractions is very easy. The numbers on the top, so all the numbers on the top, you're going to multiply, and all the numbers on the bottom, you just divide. Okay. Okay, so if we take a look at these numbers, let's multiply and divide them. So our starting number is 1,000. So you're just going to punch in 1,000 on the calculator. Okay. We have to multiply by the numbers on the top. But if it's a 1, it's going to be the same number, right? So we don't really need to do that. So all we're going to do is divide it by 149.26. Oops, that's 25. So 1,000 divided by 149.26. And that will give us our final answer. It will be 6.6, and then we'll round it up to 7. Okay, so there you go. That is your final answer. All right, so I know this might seem a little bit weird right now, the method that we're doing it. But trust me, in the long run, it will help you guys out. And we'll do another problem just to give you guys a little more practice, okay? Any questions on this one specifically? You guys all right? Yeah. Usually I like 2 to 3, but here, like, you can round that up. It's pretty close, so you can round it up. As long as your rounding is fine, then you're chilling. Yeah, what's up, Sam? We write 1 mole on the top because remember earlier we did the molar mass of meth. It was 149.26 grams per mole, right? If it's per something, it's always 1, right? Yeah. Like if you have 12 eggs per dozen, that's 1 dozen. All right, so let's try number 5. So what we're going to do is we're going to start by writing down our starting number, and we want to find our ending value. So I'm going to give you guys 1 minute, see if you guys can figure out the starting number and the ending value. Okay, so what number do you start with, and what do you want to turn that into in terms of units of measurement? Alrighty, guys, let's start with the starting number. What's our starting number for this problem? Yeah, 0.25. So we have 0.25, but specifically 0.25 what? Yeah, we got 0.25 moles, and we are going to turn that into mass, right? Now, mass in this class will almost always refer to grams. So if you're ever looking for mass, you're going to be looking for grams. So we're starting with moles of this chemical right here, CaCl2, and we're going to turn it into grams of CaCl2, okay? So again, if you ever see the term mass, you're turning it into grams. Okay, so what we can do is we can set up the fraction like we did here. We're going to write down our starting number, which is 0.25 moles of CaCl2. And then we're going to set up our fraction. All right, since we are trying to get rid of moles, we're going to put moles on the bottom of the fraction. That way these guys can cancel each other out, right? And then we're looking for grams, so we're going to put grams on top of the fraction. Okay. So far, so good on that? That's what we did last time. Now, the problem is we don't know what numbers to plug in here. Okay. So if you guys refer back to the previous problem, where did we get the numbers for this fraction? You guys remember the term? What's this number? Yeah, molar mass. So we're going to get the numbers from the molar mass. Okay, now the chemical that we're talking about is CaCl2. So what you're going to have to do is find the molar mass of CaCl2 and plug it in right here. Okay. Okay, so I'm going to give you guys 1 minute. See if you guys can calculate the molar mass of CaCl2. And then if you're feeling extra confident, you could try plugging it into the fraction. But we'll do that in 1 minute. Okay. So find the molar mass of CaCl2. All right, guys. So CaCl2, Ca is 40.08. And then we're going to add that with 2 Cls. So Cl is 35.45. So plus 35. Oops, sorry. 0.45 plus 35.45. So you should get a molar mass of 110.98. Okay. Everyone got that? Okay, so the molar mass of CaCl2 is going to be 110.98 grams per mole. Okay, so if you're confused on where we got the 110.98, let me go over it again. So CaCl2, it's made out of 1 calcium. So we're going to start with 40.08. Okay. And then you got 2 Cls. So we're going to combine that with 2 chlorines right here, 35.45. So we're just going to add 35.45 2 times. 35.45 plus 35.45. You get 110.9. Okay. Alrighty, so let's put it into our fraction now. Okay, so if you guys notice, what number is next to grams for the molar mass? Yeah, 110. So where should we put the 110 on the fraction? Yeah, the top, because grams is on top, right? And so we want to make sure they stay together. So 110.98 goes on top. Okay. So you always want to put the molar mass wherever the grams is. Okay. And so if it's 110.98 grams per mole, what number do you guys think should go on the bottom? Yeah, 1. So we'll put 1 on the bottom. And there you go. That's how you set up that fraction. Yeah, molar mass is always 1 mole. Yeah. So if that kind of helps you, just always put 1 next to moles. Yeah. Okay, let's do the math and then we'll move on to the last problem. So our starting number is 0.25. And then so what should we do with 0.25 and 110? Yeah, you want to multiply because they're both on top. So whatever numbers are on top, we multiply. And we can divide by the 1 if you want, but it's going to be the same number. So our final answer is going to be 27.7, and then we can round that to 5. So there you go. That's how many grams are in 0.25 moles. Again, I know this might seem very weird. It's kind of a new concept. So if you're having trouble still, don't worry too much. We're putting together a lot of different things. But do you guys have any questions before we move on to the last problem? You guys sure? Yeah. Yes. Yeah. As long as you give me some decimals, you're good. Actually, I do want to talk about that. So we're actually going to start getting numbers that are a little bit different from each other now, depending on how we round, depending on how we punch it into the calculator. And so going forward, as long as your numbers are close to what I get, then I won't take off any points for that. So if you round this to like 27.8, that's fine. If you write 27.745, that's fine. As long as you're not giving me numbers like 30 or like 20, you're good. Okay, as long as it's in the same ballpark. Okay. All right, so I will let you guys try the last problem on your own, and this is the last one that we're going to do together. So you're going to have to do all the components that we did last time. And this is a problem very personal to me. But my coffee usually has about 0.5 grams of, I think, God's greatest gift to man, and that's caffeine. I got the formula for caffeine right here. I want you to find out how many moles of caffeine are in my coffee. Okay. No, it says 0.5 grams already. So wrong. All right. So anyway, I'll give you guys about 5 minutes. You can work with the person next to you, see if you guys can figure it out. It's going to be all the steps. You're going to have to find molar mass, set up the fraction and everything. I'll put up the molar mass in about a minute or so just to make sure we're all on the same page. And then we'll go over it together. Okay, so good luck, guys. You guys about 5 minutes to work on this. Bring it back. Okay, so what is our starting number for this problem? Yeah, we got 0.5 grams of caffeine. And what do we want to end up with? What should we end up with? Yeah, moles. All right, guys, let's bring it together. I know finding the mole is very fun, but we need to bring it together now. All right. Okay, so we got our starting number and our ending. So we're going to start with 0.5 grams. What we're going to do is we are going to set up our fraction. Now, since we're trying to get rid of grams, we'll put grams on the bottom. We're trying to find moles, so we're going to put moles on top. Okay. So far, so good on that? Yeah, so make sure that you guys put it on the right side of the fraction. Yeah, so whatever you start with, you want to get rid of it, right? So whatever you're trying to get rid of, you put on the bottom of the fraction. Yeah, that way they can cancel each other out. Yeah, I know it's a very weird concept. And you probably weren't expecting to do this much math, but don't worry, we'll do a lot more. Okay, so we're gonna plug in this number into this fraction. Now, where should I put the 194? The top or the bottom? Bottom, yeah. You want to keep it next to grams because you see how 194 is next to grams? So we keep it next to grams. Okay, and then we said it's always 1 mole, so we got 1 mole. So when we punch it into the calculator, do you guys think we should multiply or divide? Yeah, the most important thing is divide. So because we can multiply by 1 on the top, but it's gonna be the same number, right? So the more important function is dividing by 0.94. And then for this one, you can just put 0.00. Let's round it up to 3. Let's go. Okay. And if you got that correct, you are on my list for the people I might hire later to do for Breaking Bad in IRL. All right, so if you guys want to start, I'm just kidding for the record because this is recorded. We are not doing Breaking Bad IRL, okay? Whoever's listening. Okay. Anyway, since we are almost done with class, you guys can get started on the assignment if you want, but I will give you guys time next time in class to work on it. So you don't have to do it for homework, but if you do some problems, you can get it checked faster in class, but I'll give you the entire class period next time to work on this assignment, all right?